You can use these commands to interact with the kernel and get your task done. So these are called as APIs or system calls. So, and we have seen many system calls. Okay, so there are system calls related to the processes like your fork. There are system calls with respect to file system. So we have seen open, read, write. All these are file system related things. Then for signals we have signal, sigpop marks and all that. So you have system calls which will help you interact with the kernel, and you can implement some of these commands like copy command, tar command, who command. So all these are implemented using the kernel functions or the system calls. So this architecture should be at the back of your mind whenever you write shell scripts, so you know where exactly you are in the system. Now what is the structure of a shell script? How does it look like? So first line will be a line indicating which shell you are using. So it starts with a hash, then exclamation, and then you indicate where that shell is. Usually all shell files are in the bin directory. So if you are using bone shell, you would write bash here. If you are using C shell, you would write /bin/csh, and if you are using corn shell, you would write bin/ksh. So depending on which shell you are using, the third part here will differ. Okay. And if you don't include anything, by default it will take the existing bone shell. Okay. Now any comment that you want to write, you can begin with a hash, except for the first line where hash is going with exclamation. The other lines, if they contain hash with a space, these lines are treated as comments. Okay, so the comments can be on a separate line or can be on the same line with a hash here. For example, this is comment. And then if you want to put out a prompt for the user to enter some data, then you can use echo command. Echo double quotes and then some prompt message like enter your name, and read command you can give, read some variable name. So it will wait for the user to enter the name, and that name will be stored in this variable name. Okay. And you want to check whether the name entered is non-zero or not. So you can put out a if condition here. If has to be enclosed in square bracket if you are using bone shell. Okay. If you are using C shell, then if can be written using round brackets. Okay. So for bone shell, it is square brackets. Okay. And there will be some switches like minus, that means check whether this variable name contains some string or not. If it doesn't contain anything, this will be of zero length. So you are checking whether name is zero length or not. If zero length, then you say you did not enter a name and exit with 1. And just observe if will end with a then here, and there is a semicolon after the ending square bracket. So all this is syntactical and it should be correctly written, and there should be spaces here also, here also. So it is very particular about the spaces around the variables in the if block. Okay, and then end if should be written with the reverse if like this. So if fi indicates that if block starts here, ends here. Okay, and if there is else if, then there is else if, or if it is just else, there is else keyword. We shall see that subsequently. And if you want to write a function, then functions can be written just like this: greet, opening, closing bracket, flower bracket. Within this you want to say hello $name. Now any variable that you are using name, if you want to use in an expression like this, it should be with a dollar symbol. So $name will substitute the actual name that you have entered here. And if you want to call this function, again the name of the function should be mentioned here, and then exit 0. Okay. So if this name is non-zero, it will not execute the if block. It will continue with the greet function. It will remember this and it will give a greeting message, hello, whatever name that you enter, and then exit successfully. Okay. So this is a typical shell script file. You have to save it with some name, for example, some basic.sh. Okay, and then before you execute at the prompt, okay, so you know that you are at your prompt. To execute, you have to type /basic.sh. But this will not run until you give execute permission to this. The way to give execute permission is, before you execute this /basic.sh, you have to use change mode +x and then basic.sh, so that this shell will now be executable. And then after that, if you say /basic.sh, then it will prompt you with enter your name, and if you enter a name here, everything else will follow. Okay, so shell scripts are nothing but Unix commands, or a series of Unix commands with control statement like if, for loop, switch statement, while loop, etc., and also functions. Okay, and they have to be stored with a .sh extension. And before you execute the shell script, it should be given execute permission using change mode command, and then you should execute the script. Okay, so we shall see all of this in action. All right. So I have some basic files already created. I'll take you through the basics here. So basics.sh. So as you can see here, as I told you, I'm using bash shell. So I'm not writing the first line here, hash, exclamation and all that. Directly I can start with variables. So if you are using variables, they should be names without any gaps or special characters. You can have underscore. The all variable naming conventions apply, and you should be initializing those variables. If you are reading them through keyboard, no initialization is required. Here I have a name variable, an age variable, and gender. And if I want to print the name and age of this person, I can say echo my name is $name, and then age is $age. So just observe the use of dollar symbol here. It is telling that this is a placeholder for the variable age, and it should be substituted when you execute. Right, and you can call the shell commands using dollar and store them in a variable. For example, you want to capture today's date. So date command, when you execute, it should prefix with dollar and close in round brackets, and that is stored in a variable today. And this also you can display like today is $today. And then the if statement goes like this. For example, you have initialized age to 15. So if $age greater than, so don't use greater than symbol like this. It should be -GT. You want less than, then it should be LT. And if you want greater than equal to, it's GT. Okay, so all these symbols are standard, and you must follow that conventions. Just observe, after if there is a space, then there is a square bracket, there is a space, $age again space, GT dash DT in the space, then 18 again space. So all these spacing must be taken care. So if you make a mistake like this, it will not execute. Okay, and then there should be a semicolon, and then the keyword. Okay, so this is if else if. So the after else, the else part should be ended with fi, the opposite of if. Okay. Similarly, I can have nested if, like if age is less than 13, I want to display child. Elif, just observe, else and if are combined as elif. Then I am checking whether age is less than 18. Then I am giving a prompt as minor. Else it is adult. And then the last else should be ended with fi. So this is the syntax of if then else, and also nested if then else. And when you are comparing numeric variables, you must be using less than, equal to, or equal to. Okay, these operators you must be using. Okay, but on the other hand, if you are using strings, then you cannot use those operators. You have to use equal to or double equal to, like this. So for example, I want to check whether gender is male. If male, then I want to welcome that person with Mr. And if it is female, I want to welcome that person with Miss. Okay, so these variations you should be aware of. For string variables, it should be regular, equal to, or double equal to symbol. Okay, and then this is again if and if then else. So once you get this program typed, the first thing that you would do is change its execute permission to execute basics.sh. Nothing happens. Only thing is, if I do ls minus l basics.sh, you will see that it has execute permission. The owner will have execute permission, and also all others and group members will have execute permission. The X will appear here. Now to execute this, you have to type like this. So as you can see, my name is Pooja and age is 15. Today is whatever date, and age is below 18, so it is minor. So it is female, so it is giving welcome Miss Pooja. So this is the very simplest shell script possible. Alright. So if you look at some more examples, we shall see what all you can do with shell scripting. So I have another file here, basics1.sh. Now when you want to read, you can first say echo, enter name, and then read name. If you want to combine the two, you can just say read minus p, then the prompt, and then the variable name. So you can combine echo and read in one sentence. So that is one variation that is possible. So here I am reading name, age, and gender, and doing the same thing all over again. So it is more interactive now. So I already changed the execute permission of this. So if I say basics1.sh, it will ask for the name. For example, age 22. Now it says and all this data will be displayed, and he is major and is adult, and as you can see, it is welcome Mr. Vinod. So interactively you can take the data in, process it with a shell script. So that is another variation that is possible. Now how do I write loops and use them? So I have a program for that. So basic loops. So for instance, I want to print hello 4 times. So the way to write is, for I in, you can specify the range here, 1 to 4 or 1 to 10, whatever, and then do done. So just observe, you just don't write echo directly, you have to use do done. That indicates where is your for loop starting and where it is ending. Okay, and then echo hello $i. So this will print hello 4 times. And if it is strings, you want to display one by one. Then for fruit, this is a variable name which will take on three values: apple, banana, mango, and you want to display these fruits one by one. Then say echo $fruit. Just observe, I am using dollar and the variable name in the loop. So the for variable fruit is what should come in the echo statement. Similarly, if you want to use while loop, again while loop starts with a square bracket, there should be space, dollar count less than 5, do echo dollar count. But just observe how to increment count variable. You cannot just say count equal to count plus 1. It should be count plus plus and closing, 2 opening round brackets and 2 closing and round brackets, and done. Similarly, if I want to use switch statement, it will be case $in. So for example, I want to read some number n. So I give a prompt read -p enter n and read that into variable n. Case $in, if it is 1, then I am going to this statement and echo like this, and there should be 2 semicolons. Just observe this. If you write only 1 semicolon, it doesn't work. The syntax is like that. I don't exactly know why they are using 2 semicolons. Maybe just to indicate that it has to break and exit this switch statement and then go to the last statement here. And just see the case should end with the ESAC, which is opposite of case. A reversed string of case, ESAC should come here. So the syntax is little peculiar, but this is how you should remember. If should end with FI and case should end with ESAC. Now if I run this program, basic loops, as you can see, the hello got printed 4 times. It listed all the 3 fruits, and then the while loop went from 1 to 4, and now it is asking for some number 1 to 3. So if I write 1 here, it says 1. If I enter 2, it says 2. If I enter 3, then 3. And if you enter anything else, it says indent. So these are very basic things that you should begin with. Of course, the syntax gets very complicated when you actually use them in a real life scenario. So the scenario I've chosen is if I were to create 100 users or 10 users and allocate space for them. So how would a shell script look like? Okay, this will be very useful for administrators. So there is a program here, users.sh. So create users.sh. Just observe this carefully. So the command says loop to create 10 users. So just see the familiar for loop here for I in 1 to 10, and there is a variable username. So you can choose the variable names like Unix user, and then it will create Unix user 1, Unix user 2, like that. For every I, this variable will be changing, if you can observe. And you want to allocate space for each user on a separate folder. So /home /username _ disk image. Okay, so there will be specific space that will be created, and that is where the disk space allocation is done. And then you just give a echo message creating user, whatever is the username that it has created here. And actual user creation is happening here. As you can see, user add -m $username. So this will create the user, and it will create a disk space in this home page or home folder. And then you have to set password for each user. So there is a command to change password. So change password is chps word will be there, and the password assigned will be password 123. So every user will be password 123. Subsequently, when they log in, they have to change it. And now you want to allocate 100 MB disk space for each user. So this is where the command dd will come. Okay, so this dd command, disk drive command, will go to the device file. See, device files are by default created, device 0, device 1, like that. On that, the disk file will be whatever disk file that you have mentioned here, and the size of the space will be 1 MB and count equal to 10. Okay. So this disk space will be created for you, and once the space is allocated, the ownership of the disk space will be given to the user. As you can see, change owner username, $username, $disk file, and then the disk file itself will have both read write permissions. So 6 means 110. So both read write permissions will be given, and then you can give a message saying that allocated 100 MB disk file to username. And after the loop is done, you have to echo saying that all users are created successfully. Okay, now if I run this program, as you can see, it failed to allocate space because it doesn't have super user privilege. So you must execute this with sudo command. So you should have super user privileges, only then it works correctly. So as you can see, it created user 7, user 8, and allocated the 10 MB space on the disk. Okay, so if you want to check whether it has created the user correctly or not, you can go to the shell prompt and type one of these username, Unix user login Unix user 1. Okay, so you have to say sudo login Unix user 1. It is asking for the password of this. So I think so it was password 123. Okay, so it logged on to your home folder. If I say pwd print working directory, as you can see, it has created a folder /home Unix user 1. Okay, so this is where you can start working, and you see the image file. So in this image file, all the files will be saved. So you can do a cat command here and then say test hello world, and then Control Z, and if I give ls, this has created the test file. Okay, if I give ls -l, it will show. Okay, so you are the owner of the file Unix user 1, and the file size is 12 bytes, created on 16th February. Okay, so you can simplify many of the administrative tasks. So this was done basically to simplify the administrator's work. Imagine you have to create 200 users. You are working in a large organization where 200 employees are there, and all should be given login credentials with their own username and passwords. Doing it manually will be a Herculean task, and you sometimes mess up with the user's name that you create. Just write one shell script, mention the range of users, and automatically those many users will be created, and automatically the disk space will be allocated. Okay, so if whenever the user crosses that 10 MB mark, then the file creation fails. Okay, so since it is a multi-user operating system and the disk space is limited, you must have the provision to limit the disk usage space, and that is done through the dd command. Okay, so this is one practical usage of writing a shell script. Okay, any doubts here?
No, sir.
You have followed what shell scripts are? Okay.
Yes.
So only thing is you should get acquainted with the shell script syntax. Now these are all bone shell scripts what I showed you. If you look at the C shell, they are also similar, just that they follow C program syntax. So for example, let me show you users.sh. So it will show who all users have logged in. So it's a very simple thing, as you can see, exclamation /bin /css. So this line should be there because I want to use C shell now. So it should be explicit. And if you want to print who all have logged in at this moment, the command is just who. Okay, and if you want to print anything else, that should be fine. So here chain plus x l users.sh dot l users.sh. So as you can see, right now 2 users have logged in. One is myself and the other one is Unix user 1, which we created in my previous tab. Okay. So this is a C shell script to list who all have logged in. Okay. Similarly, we have uptime. So since what time your operating system is up. So there is a shell script and yes, uptime. So just here to execute the uptime command. I've kept it very simple so that you understand the syntax of that. So it will print there are 2 users and it is up since 1 hour 55 minutes, whatever. Okay. Similarly, you want to know what all processes that are running. So I have one shell script for that. So this is slightly involved. So ps is the command to list all the processes, and you want to check what all processes are running except the grep command, because grep you are typing here. Okay, this should not be listed. So for that, to suppress the grep command, grep -v grep should be done. So grep is a command, it stands for globally search and replace the pattern. Okay. So whatever is the ps command generates, that will be passed. As you can see, vertical line indicates that there is a output of ps command is given to grep command. The grep command is given to again grep command to suppress the grep command and give only the processes which are running. So if processes are null, then bash is not running, otherwise bash is running. So you want to check whether which shell is running now. Okay. So if I run this command, so it is showing bash is running. Okay, so we have both the shells here, bash shell and C shell. It is currently by default it is showing bash is running because you are in the bash shell. So you can have numerous such things. Similarly, if you want to okay, I forgot to mention about functions. So how do you write functions and execute them? I showed you one of them, but you need to see how functions are written. So functions start with the name, and then within the body of the function in curly brackets you write all the instruction. You can write for loop here or whatever. So for instance, I wanted to print hello, whatever argument that you want to pass to greet 3 times, then you could write a for loop here. So for I in 1 dot dot 3 echo $1. So this $1 is coming from the argument that you're passing. So I am calling this greet function with one argument, right? So $1 refers to the argument that follows the name of the function. If I wanted to print the name of the function itself, you would have written $0. If I write $0, it will display greet, the name of the function itself. I want Ajay to be displayed 3 times. Similarly, there is an add function which will take two values that are passed and store that result and display that. So as you can see, add 3, 5. $1 is 3 and $2 is 5. So that is how, see, I am not passing these arguments in brackets like this, the usual way that you do, and within this function you will take some variables here. You don't take variables here. This will be always blank, and what you pass to the function will appear as $1, 2, 3 like that. So always function should, when you invoke, there should not be any bracket, just the argument should follow, and these arguments will be available to the function through dollar symbols, $1, 2, 3, whatever. And if you say $, then all arguments will be acceptable. You can use a for loop to access individual elements of that. But if you want to use the result of add, this is not returning any result. As you can see, there is no return result, something like that. But if you want the value to be returned to the calling function, then it should be with a dollar symbol here. Dollar opening bracket, name of the function, then the arguments, and close the bracket. So this will return the sum into a sum variable, and again you can display the result in the main function also, or main script also. I am displaying within the function also and also outside the function. So if I run this program, there is some syntax. I think so. Is it square bracket? No. Syntax error, unexpected token, line number 5. So let's remove this for loop for a moment and check.
So that should be $I, right?
No, not $I, it should be $1.
Okay.
Because I am passing only one argument, no? I think so the syntax error was in the for loop. Yeah, not going through. Yeah. So for loop has to be correctly written. The syntax I will check and let you know. So as you can see, the hello Ajay is coming because the function is called, and within the body of the function you are saying hello $1. So $1 contains Ajay and it displays that. And this 8 is displayed in the function, and this is displayed outside the function. Result equal to 10. Are you getting two different results? Because here I am passing 3 and 5, I am getting 8, and here I am passing 3 and 7, I am getting 10. That's right. Okay. Alright. So you should get acquainted with the syntax of writing functions, and also writing if blocks, writing for loops, writing while loops, and implement some useful system requirement like creating 100 users or allocating disk space and doing all kinds of administrative functions. So if you look at more complex shell scripts that are available for doing many things, the syntax gets very complicated. So what I've covered today is very basics of how a shell script look like and what all you can do with the shell scripts. Is that fine? I'll share all these programs with you. Just go through, and if whenever you encounter a situation where you have to write shell script, I'll get back to you. All right?
Sir, yeah, thank you.
Okay. So we'll stop here today. Do you require a completion certificate?
Yes, sir, it will be better.
Yeah. So I'll include all the 4 courses which I've covered, and the date I'll check when you started and maybe till today. And if whenever you have any specific requirements, okay, as part of your development role, you just share the details with me. We shall have a couple of sessions to cover that.
Okay, sir, sure.
Okay then. Okay then. Bye.
Thank you so much.
Yeah, sure.